Box plots. Box plot is a visual representation of the statistical summary of the given dataset. The summary includes minimum value, first quartile, that is the point below which 25% data lies. Median, second quartile, 50% of data lies below median. Third quartile, 75% of data lies below third quartile. Maximum, and the outliers of the dataset. So let us run the below entry to generate a box plot of horsepower. So let's do this part now. df cars dot box plot, open round bracket, column equal to open square bracket, horse power, shift enter. So what does it say? The above graph clearly shows a collection of points above the maximum value, which are the outliers. Below entry generates a more classified information horsepower distribution grouped by the cylinders. So let's try to generate this. So let's try out the next instruction now. df underscore cars dot box plot, open round bracket, same as earlier, same instruction as above, almost same, only grouped by cylinders. Column horsepower, go next position, y equal to cylinders. So shift enter. So here we have the another one. Dealing with outliers. Now here is some consideration of what should be our strategy in case of outliers. Outliers are exceptional data points lying outside the maximum or minimum limits, and often they adversely affect the machine learning performance. So should we remove outliers from data? The answer is it depends on the data pattern. Many times it's a good idea to simply remove the outliers, especially if the rest of the data is homogeneous. Let us say in our earlier example, the distance traveled. If the vehicle had halted a couple of times for a few minutes, that would have generated an outlier. There we knew for sure that this was an one-off issue. Therefore, we could easily drop that outlier and forget about it. This is because the rest of the data is consistent and homogeneous. But in many situations, it's not a good idea to indiscriminately drop the outliers because they have some important fact connected with them. For example, in banking transactions, frauds appear as outliers. In aircraft signal processing, outliers give indication of some technical snag, which can lead to an emergency. In ECG, heart problem appears as an outlier. So basically, there is no one golden rule on this, and we need to study the root cause of the outlier before deciding on it. So today, just to know the process, we will first see how to remove the outliers and then come back and see another approach as to how we can group the data differently to get better results than removing the outlier. So removing the outliers from data frame. In the below example, we are setting a mask of upper cutoff point at 20% from top and then simply removing the data lying outside. So let's first check the initial number of rows. So here the instruction, we check len open bracket df underscore cars square bracket horse power. So length is the number of rows. Shift enter. So we have 394 here. So let us set the upper cutoff limit. So that is upper. Let's define a field called upper. Upper equal to df underscore cars open bracket horse power dot, now close bracket and dot quantile round bracket 1 minus 0.2. So we want to cut off the limit, set the cutoff limit at 1 minus 0.2, that is about 20% from top. Then we will check the value of upper. So let's run this instruction, shift enter. So we see that it's 140. So our upper limit is set at value 140. We are removing only, remember that we are removing only top portion where all outliers are located. Now let's set up a mask that will work on this cutoff. Okay. So let's define the mask. Mask equal to round bracket df underscore cars open bracket horsepower. Now where do we want to set the limit? Is less than upper. So we want to keep only so many rows in our data. So mask equal to df underscore cars horsepower. This is our column. In this column, whatever is the content below upper, that is only we are retaining. Shift. So we have done this. Now below entry will knock off the top portion from above the mask. Note that we are creating a copy for testing purpose so as to keep the original data intact. We don't want to disturb the original data. Simple as that. df underscore cars01 equal to df underscore cars mask. So this will operate on the mask. Now we check the effective length, how much we have cut it off to. Okay. So length of df underscore cars 01. Shift enter. So 314. So now double check. We have 394 on top and now we have 314. So we have removed the data points between, that is top 20%. Now there is one more box plot, that is another option to how to check the box plot. Now this truncation part we are not doing actually. Let's check the next instruction, SNS dot box plot round bracket x equal to, see here we have an option of setting which axis we can have the box plot horizontally or we can have it vertically also. X equal to df underscore cars 01 open bracket horse power. Shift enter. Okay. So here we see the box plot. Now what do we see here? The response shows that the earlier outliers are now removed. So now this demonstrates how we can drop the outliers. Now there is something new we want to know. This is SNS count plot. All these plots that we have seen so far, they process numeric values. A count plot, in contrast, can be thought of as a histogram for categorical variables. It is used to find the frequency of each category. So the only categorical variable we have in the data are the origin. For example, the origin country. The country is US or Japan or Europe. So let's see how we can get how many data points, how many car models in our data of each type, like US model, Japan model and Europe models. So SNS dot count plots, like box plot, this is a count plot. Round bracket df underscore cars dot origin. Shift enter. So we have this count plot here. So we can see that how many models are, European models are there in the data, how many Japanese are there, how many US are there.